Welcome back to Biomindscape. Today we are going to know about the diversity index. So diversity index is a mathematical measure of species diversity in a particular community. So it is a measure of number of species in an area and the relative abundance of an individual among those species. So number of species means it can be plant, it can be animal, or it can be something. So their numbers they are present, and in abundance they are present in a particular area, that is the abundance of that particular species. So species evenness is the abundance and species richness is the number of species. So a variety of indices have been used for estimating the species diversity. So we can divide them broadly into two categories. So the first category is the dominance indices, and second is informational statistic indices. So diversity indices are the mathematical measures of the number of species, that is species richness in a particular area, and the relative abundance of individual among those species, that is the species evenness. And there is a rank abundance plot, a graphical representation of number of individual per species against rank of the species in a community. So that is the rank abundance plot. So we can see here, now I am going to show that rank abundance plot in this particular diagram. So it is like this. There is a graph here. Here abundance rank is present, and relative abundance in the y-axis, it is something like this. For example, this is a forest community, and this one something like this will go. This is the forest community 2, forest community 1 and forest community 2. So this is the abundance rank on x-axis, and on y-axis we have relative abundance. So rank abundance curve for two forest communities is shown here. So in rank abundance plot, the abundance of each species is plotted on an logarithmic scale against the species rank in order from the most abundant to the least abundant species. So here the x-axis represent the abundance rank, and the most abundant species is given in rank 1, and the second most abundance is given in rank 2, and so on. So the y-axis represents the relative abundance, and relative abundance is expressed on the log 10 axis. In this plot, the richness and evenness of the two forest community are plotted, and the forest community 1 uh, is given here. It has a high species richness, length of curve, and evenness, slope of curve than the forest community 2, which is the second one, which is given here. Now let's know about the Simpson Diversity Index. So we know what is the species richness and species evenness. Now Simpson Diversity Index is a simple mathematical measure that characterizes the species diversity in a community. So the term Simpson Diversity Index can actually refer to any one of two closely related indices like Simpson Index or Simpson Index of Diversity. The Simpson Index D, it is denoted by D, and it is measure of the species diversity on an ecosystem based on the concept of dominance. So it measures the probability that the two individuals randomly select from a sample will belong to the same species. So it is actually a measurement of dominance. So there are two versions of the formula to be calculated, that is D is equal to summation of the relative abundance of each species, that is small n upon capital N, and small n is the total number of individual of particular species in a sample, and n is the total number of individual of all species present in the sample. So for final community, this comes to be D is equal to summation of small n minus 1 upon capital N in bracket n minus 1. So D is the measure of dominance. So D increases. So the diversity in sense of evenness decreases. So the value of D ranges between 0 to 1. With this index 0 represent an infinite diversity and 1 no diversity. So that is the biggest the value of D and the lower the diversity. So Simpson index is usually reported as an its complement 1D. It is known as the Simpson index of diversity, and the value of this index also ranges between 0 to 1. But now the greater the value, the greater the sample diversity. So in this case, the index represents the probability that the two individuals randomly select from a sample will belong to different species. To understand Simpson diversity index, let's take an example of forest community which have five different species. For example, we have taken five different species like species 1 like mango, ashoka, then cashew nut or coconut. So and one plant like amaltash. So here n will be represented here. For this for mango it will be 2, for ashoka it will be 8, for cashew nut it will be 1, this one for coconut also 1, and for amaltash it will be 3. So we will make a table, and in this example we will find the value of the Simpson index. So here the value of n is given. Now what we are going to do, we are going to minus the apply this in formula and this minus it. So it will be like 2 in bracket 2 minus 1. Similarly 8 in bracket 8 minus 1. 1 in bracket 1 minus 1. So in this way we will calculate this one, where n in bracket n minus 1 we are going to put up. So the value here, and we are going to make this similar 3 in bracket 3 minus 1. So it will be just calculate the value, and you will get 2 56 0 0 6 and 64, the final one. So in this diagram, we can find out so n we have to total it 2 plus 8 plus 1 plus 1 plus 3. So which comes out to be n is equal to the total number is 15, whereas n in bracket n minus 1. So for mango it is 2, for ashoka it is 56, for cashew it is 0, for coconut it is 0, and for amaltash it is 6. So the totals come out to be 64. So here we will just put up the formula for this, which comes out to be D is equal to summation of n in bracket n minus 1 upon capital N in bracket n minus 1. So which comes out to be here 64 upon 15 in bracket 15 minus 1, that is comes out to be 14. So the answer is 0.3, 0.3. So Simpson index, that is capital D, that comes out to be 0.3, whereas Simpson index of diversity 1 minus D, which comes out to be 0.7. So here we get the Simpson index, that is 0.3. Then what is the Simpson diversity index? So Simpson index, that is D is equal to summation of pi2. So D represent the probability that the two individuals randomly choose from a community belonging to the same species, which ranges from 0 to 1, where 0 is infinite diversity, very unlikely both are same species. 1 is equal to number of diversity, only one species, so lower D means higher diversity. Then Simpson index of diversity 1 minus D. So to make it easier to interpret, where higher is equal to more diversity, we often use Simpson index of diversity is equal to 1 minus D. So we know that the Simpson index which we got, that is capital D, is equal to 0.3. So we will minus it. 1 minus D, that is 1 minus 0.3, that comes out to be 0.7. So the Simpson index of diversity is equal to 0.7. So D is equal to 0.3. Moderate probability that two individuals belonging to the same species, and 1 minus D, that is 0.7. Fairly good species diversity, that is closer to the one mean, more diversity. D is equal to 0.3 means that is a raw probability measure, and 1 minus D is equal to 0.7 means biodiversity measure. It is easy to interpret, more higher, so it is more better. So welcome to Biomindscape. Today we are going to know about various hypotheses which are related to the species diversity and ecosystem function. So does the loss of species affect ecosystem function? That is the community services, the ecosystem function. So yes, but the effect depends on what hypothesis is applies. So the first one is the reward hypothesis, which was given in 1981 by Paulin and Enlich. The idea was every species is like a rivert in an aeroplane. Now, what is a rivert? It is like a pin or bullets that attaches the aeroplane's parts, and any of the part, if it's not working or many of the parts are not working, so it will not be working, the aeroplane will not be working. So like that, in the revert hypothesis, every species is like an important part of an ecosystem, the rivert, and without it the ecosystem would not work. So every species is like a rivert in an aeroplane, and each species has an important role. It adds a small but important function, and losing one of the species may not cause collapse, but losing too many weaken the system. It can weak all the systems. So graphically, stepwise upward, it is given here, and each species add the function. So all species matter equally. Example, pollinators in agriculture. Each insect, each species adds stability. Then the second one is redundancy hypothesis, which was given in 1992 by Brian Walker, and the idea was many species play a similar role. Some many have same role, so it represent the redundancy. So it is loss of one species may not affect the function, but because others can compensate, that is fulfilling the others work. But if too many species are lost, then ecosystem function declines. So rapid rise, then it will increase and then plateau. So backup species are present, and examples are like grassland plant in nutritional cycle, and different grasses can perform similar roles. Then keystone hypothesis is some species, that is a keystone, are critically important, and loss of the keystone species immediately collapse of the ecosystem services. Even a small decline in richness can have a huge impact. Like flat line, in this graph it is given a flat line, and it's sharp the rise at keystone point. So one species will have a huge effect. So like wolves in Yellowstone National Park, it controlled the population and restored the balance. Then the last one, this one is the effect of species richness, where the species richness is unpredictable, and in this hypothesis there is no fixed pattern. So it is known as the idiosyncratic hypothesis. In some species there is increasing function and other decreases, and some do not. So it is random ups and downs. The graph show random ups and downs. So it plays an unpredictable role of biodiversity, and in soil microbes some species may promote growth and some inhibit, whereas some are neutral. So these are the four types of hypothesis, like rivert, redundancy, keystone, and idiosyncratic hypothesis. So let's know about little bit in short about this. सो लाइक बायोडाइवर्सिटी और इकोसिस्टम फंक्शन के बीच में चार मेन हाइपोथेसिस है. द राइवर्ट हाइपोथेसिस वेयर हर स्पीशीज़ एक एरोप्लेन की तरह राइवर्ट की तरह है. एक दो अगर गए तो ज़्यादा फर्क नहीं पड़ेगा, लेकिन ज़्यादा स्पीशीज़ गए तो पूरा सिस्टम वीक हो सकता है, मतलब सब स्पीशीज़ मैटर करते हैं। देन रेड्यूडेंसी हाइपोथेसिस, कई स्पीशीज़ सेम काम करते हैं, इसलिए एक दो गए तो कोई टेंशन नहीं, लेकिन अगर बहुत गए तो इकोसिस्टम सर्विस कोलैप्स हो जाएगा, मतलब बैकअप स्पीशीज़ होनी चाहिए। देन कीस्टोन हाइपोथेसिस, कुछ स्पीशीज़ बहुत इंपॉर्टेंट होती है, अगर वो गई तो पूरे सिस्टम कोलैप्स हो जाएगा, मतलब एक ही स्पीशीज़ का बहुत बड़ा इफेक्ट होता है। देन आइडियोसिंक्रेटिक हाइपोथेसिस में यहाँ कोई फिक्स पैटर्न नहीं होता, एक कुछ स्पीसीज से सर्विसेज बढ़ती है और कुछ से घटती है, लेकिन कुछ से न्यूट्रली रहती है, कुछ कम नहीं होती है, मतलब बायोडाइवर्सिटी का इफेक्ट अनप्रिडिक्टेबल है। सो ओवरऑल डाइवर्ट एंड और रिडरेंस रेड्यूडेंसी इकोसिस्टम को स्टेबल बनाता है, वेराज द कीस्टोन जो है स्पीशीज़, इसका रोल दिखता है, और आइडियोसिंक्रेटिक अनप्रिडिक्टेबल है। कीस्टोन क्या है, क्रिटिकल वाला है। सो दिस वॉज ऑल अबाउट द वेरियस टाइप ऑफ हाइपोथेसिस। थैंक्स फॉर वॉचिंग, डू लाइक शेयर एंड सब्सक्राइब।